Page 3 on your review begins with problem 8. This is another quantitative comparison. This one's much easier than the one we did on the other page. This says the sum, we're going to compare the sum of two negative integers to the quotient of two negative integers. We know that sum means addition, so I could just pick any two, -5 plus -4. And no matter what the two negative integers are, if you're adding two negative integers, you're going to get a negative sum because you can think of this as like owing money. This is like a debt of $5. If I owe somebody $5 and I owe some other person $4, if I combine those, it's like owing $9. If you think about a number line model, oops, having trouble with that. If 0 is here and -5 is here, when I add a -4, adding a -4 will take me 4 more to the left, and I end up at -9. So the sum of two negative integers will always be negative. We don't know what the negative sum will be, but it will always for sure be a negative number. The quotient of two negative integers, on the other hand, like -9 divided by -3, will always be positive, because this means how many -3's are in -9. There are 3 -3's in -9, positive 3. So this will always be positive. And if the quantity in box A is always negative and the quantity in box B is always positive, then B is always greater than A. A is less than B, which is the same as saying, if you read it this way, B is greater than A. That has to be true. Problem number 9 asks you to represent each of the situations with an appropriate integer and then order the integers from least to greatest. Oops. Forgot to click on that. Okay. A gain of 5 yards in football. If you're gaining 5 yards, that's +5. And I'm not going to put a plus sign for +5. You could if you wanted to, but if you just see an integer with no sign, it's you assume it's positive integer. 50 feet below sea level is like 0. Below sea level would be a negative, so -50. The stock price falling by $8. If it's going down, it's like adding a negative, so it's -8. Depositing a $115 check. Deposit and withdrawal are the tricky ones, because it seems like if you're taking $115 out of your pocket and putting it into your bank account, it seems like a negative thing, because the money's not in your pocket anymore. But when you're depositing a $115 check into your checking account, you have to think about, how does it affect your checking account? Your account balance goes up, so a deposit is positive. So this is positive 115. A withdrawal, you're taking $40 out of your bank account, maybe from the ATM, then your account is going to go down, so that's -40. And the money in your pocket goes up, but the withdrawal and the deposit are referencing your bank account balance. A debt of $100, that's -100. We refer to negatives as debts often to help us understand the operations for integers. Climbing 40 feet per second, you're going up, so that's +40. And then a temperature of 23 degrees, it's positive 23. If it said 23 degrees below 0, that would be negative. Okay, now we have represented all of our integers. Sometimes when ordering integers, it helps to think of a number line and 0 as a reference. 5 would be, actually, let me look at all my positive integers. I have 5, I have 115, I have 40, and I have 23. Which one of those would I see first as I'm moving to the right? 5 is the least, so I would see 5 first. And then of these three, I would see 23 next. And then 40 would pop up here way before 115. So we've placed all our positive integers on the number line. The negative integers, as I'm moving left from 0, the first one of these I would see would be the -8. And then as I continue to move left, I would see negative 40 just before negative 50. So negative 40 might be out here, negative 50, and then negative 100 would be way out here. So an ordered list from least to greatest is like going from left to right on your number line. So here's my ordered list of integers: negative 100, negative 50, negative 40, negative 8. I'm not going to show 0 because it wasn't one of our integers. It's just used as a reference point. It's the origin on the number line. Next is positive 5, positive 23, positive 40, and lastly positive 115. Least to greatest would be the same as ascending order, going up. Okay, the last problem on page 3. There's quite a bit to this problem. It says a single buckyball. Those are those magnetic balls, which are not very safe, by the way, so I wouldn't recommend using those. A single buckyball has a volume of 55 hundredths milliliters. Volume is the amount of three-dimensional space that the ball takes up. So if you drop it in water, it displaces that amount of water and the water rises. A cluster of buckyballs, so many buckyballs, is dropped into a graduated cylinder as shown. Graduated cylinder is the type of cylinder you might use in science where there are markings on the outside, kind of like a ruler, so you can measure volume. This causes a rise in the water level, as you would expect. How many buckyballs are in the cluster? Well, the volume of the buckyballs will be equal to the difference in the volume of the water, from this state to this state once they're dropped in. So we have to find the difference in this water level first. I have 1 and 3,188 10,000ths minus 1 and 2 tenths. I can't subtract tenths from 10,000ths. I need like terms, so I'm going to show there were always 0 hundredths here. I'm just showing it. Likewise, there are 0 thousandths and 0 10,000ths. Now I can subtract 8 minus 0 is 8, 8 minus 0 is 8, 1 minus 0 is 1, 3 minus 2 is 1, and 1 minus 1 is 0. So the difference in volume, something very wrong with this problem. No, there isn't. I just forgot. Okay. I fooled myself. Okay. This is 1,188 10,000ths. But here's why I got confused. 1,188 10,000ths what? The unit for the volume here is liters. So this is liters. The reason I was confused is I expected the volume change in the water to be many, many times larger than the volume of a single buckyball, because clearly there are lots of buckyballs in this cluster. And it is much greater than this volume, but I didn't notice the difference in the units. So in order to complete this problem, we want to know how many 55 hundredths milliliters are in 1,188 10,000ths liters. But you can't do that when the units are different. You have to have the same units. So I'm going to convert these liters to milliliters so we can then take the problem from there. You remember, well, I'm sure there's a reference. Actually, I'm certain there is. I think it's on page 4 since we haven't done it yet. But there's a reference for converting in metric units, and it will be on your test as well. But you've got your base units, which liters is a base unit, and then you've got King Henry doesn't usually, so you might think of this as a U for units. Drink, chocolate, milk. So this is should have been a little d. So milli is right here. So if I'm going from milliliters to liters, if I'm going from liters to milliliters, my units are getting smaller, so I should have more of them. So I'm going to move my decimal 1, 2, 3 places to the right. But that's the same as multiplying by 1,000. Every time you move your decimal 1 to the right, it's like multiplying by 10. If I multiply by 10, then multiply by 10 again, that's multiplying by 100. If I multiply by 100 by 10, that's multiplying by 1,000. So when I convert from liters to milliliters, I'm just multiplying by 1,000. So now I have 118 and 8/10 milliliters. That's equivalent to the number of liters we showed before. And I want to know how many of these 5500ths milliliter balls are in this 118 and 8/10 milliliters. So that's division. I'm going to divide the 118 and 8/10 milliliters by 5500ths milliliters to find out how many buckyballs are in this cluster. So now we have a decimal division problem. 118 and 8/10 is my dividend. My divisor is 5500ths, and we don't like that. We'll deal with that in a minute. I don't want to have to think about how many 5500ths are in one. It's just much easier to make your divisor a whole number. And so in order to do that with 5500ths, I need to move the decimal 2 places to the right. That's the same as multiplying by 100. If I multiply my divisor by 100, I have to also multiply my dividend by 100. So my decimal's here now, and I put a 0 in the ones place. Multiplying your divisor and your dividend by the same factor is just the multiplicative identity. It's just multiplying by a form of 1. Now we can ask how many 55s are in 1? 0. How many 55s are in 11? 0. How many 55s are in 118? Well, 50 doubled is 100, so maybe 2 55s will fit in 118. 55 times 2 is 100 plus 10, so 110, so that's great. 2 55s is 110. Subtract, get a difference of 8, bring down this 8. How many 55s are in 88? 1. 155 is 55. Subtract this and I get a difference of 33. Bring down this 0. How many 55s are in 330? Exactly 6, because 6 50s is 300 and 6 5s is 30. So I get a difference of 0, so we're done. So the answer is 216 buckyballs in the cluster. That was a hard problem. We needed decimal subtraction and then decimal division. Okay, we'll complete the review of page 4 on the next video.